Here's an example. Write the vector with tail at, P is just labeling the point, so the tail is at 1, 3, and I'm calling that point P. So that's where the tail is, and the tip is at the point 3, 5, and I'm calling that Q. And I want to write that in component form. Well, I'm developing a formula for doing that in general, so let me draw this to show you kind of where the formula comes from. Remember, the component form, when I say component form, I'm talking about what I originally called delta x, the horizontal component, delta y, the vertical component. And we're referring to between tail and tip, the change in the horizontal versus the change in the vertical. Delta x being the change in the horizontal, delta y, the change in the vertical. So visually, you can see what that is, right? What would that be? Yeah, so the delta x would be 2, and the delta y would happen to be 2 as well. So that's it, right? But you don't want to draw a picture every time, do you? So what's the formula? You guys know the slope formula, right? M is rise over run. Let's use what we know and connect it with what we're doing here. So we know that with regard to slope, we call the delta x, you're used to calling that the run, right? We know that we, in the past, have called delta y the rise. So another way of thinking about it is, we're not finding the slope, right? But it has the same elements of the slope. The component form has the same elements of the slope. We're finding the run for the delta x and the rise for the delta y, aren't we? But you know the slope formula. Remember, y2 minus y1 is your rise, right? x2 minus x1 is your run. So if we, now you do want q as your x2, y2. So if we take 3 minus 1, isn't that your run? And if we take 5 minus 3, isn't that your rise? Yeah. So take what you're already familiar with, the slope formula, and use it to do something new. So if you want the component form, let's use a more generalized point, when P has coordinates, let's say x1, y1, and Q has coordinates x2, y2, that form then is, okay, I'm going to write PQ. By the way, I should have done that up here in this example. We'll use the notation PQ with a little half arrow above it. And I'll do the same down here. So same situation. The tail is P. And the tip is Q. Then if you want to write that in component form, delta x, delta y, then PQ is going to be, well, x2 minus x1 for the delta x, the same as the run for the slope, then y2 minus y1, same as the rise for the slope. But again, it's just another way of saying delta x, delta y. Okay, does that make sense? So this is a formula, you guys. You're given 2 points, a tail and a tip. That's a formula for converting that vector with given tail and tip to component form. Now, there's a neat way to think about it in terms of the tail and the tip. What are we doing? We're taking the tip minus the tail. I find that difficult, though, because they both begin with T. But I think it's neat to say. So PQ is also, and it's a neat observation. You take the tip. Well, okay, the tip is a point minus the tail, but we're really thinking of the same sort of subtracting corresponding coordinates this time, right?